This video talks about how to implement a simple astronomy museum implemented by WebGL. The video content will involve the following aspects: a brief introduction to lighting, shadows, some interactive elements, texture mapping, and bulletin board. And we will introduce how to implement the bulletin board and the interactive elements in detail. There are three different light types of light sources in our scene: parallel lights, a moving point lights, and ambient lights. Here, this geometry is used to record the location of the moving point lights, and its position will change over time. In addition, we can see that when the light source is away from the objects, the shadow becomes smaller. In the default, it is turned on. When we click the moving point light button, the light will be turned off, and the light will be turned on again when we click the button again. Same for the ambient lights and the parallel lights. We can control them by clicking the ambient lights and the parallel lights buttons, and the slider here controls the brightness of the parallel lights. When we turn off the ambient light, we can see that the direction of the parallel lights for all vertices are the same, while the direction of the point light source changed with the position of the vertex. In addition, we add keyboard events to control the color of the moving point lights. When we hit the keyboard R, you can see the color of the point light source will turn to red. When we hit the keyboard G, it will turn to green, and we hit B, the color of the point light source will turn to blue. In the default, the color of the moving point light is red. And we also use the keyboard WASD to control the movement of the camera. W goes forward, and A goes to the left. S goes back, and W goes to the right. We can control the field of view by moving the mouse. You can see when I drag to the left, the scene will move to the left. When we drag back, it will come back. To implement a simple astronomy museum scene using WebGL, texture mapping is important. In our case, the wooden texture feature here is used for the walls and floor of the museum, and the texture of the top here will change over time, constantly change. To enrich our scene, we've added a solar system model. Different spheres here are different ways of moving and have different texture. We also loaded a female model in the object formats into our scene and used the bulletin board here to make a fake 3D object effect. This is because the bulletin board is always perpendicular to the direction of view, which makes the bulletin board always face to you and to create a 3D effect. We will specifically introduce how to control the camera and the field of view through the mouse and keyboard events, and to make a bulletin board. We use keydown events to change the parameters in lookup and to move the camera. Parameter I here represents the camera position, and value camera lookup represents the direction of viewing. When we hit the W key, the eye will move along the viewing direction. When we hit the X key, the eye will move in the opposite from the direction of the view. Note that the parameter X needs to be changed as well. The value right dir stands for the direction, which perpendicular to parameter up and direction of view, which can be understood as the left-hand side of the observer. When we hit A, the position of the camera will move in the direction of the right dir. And when we hit D, the position of the camera will move in the opposite direction of the R of the right dir. We use mouse down, mouse move, and mouse up events to record the position of the mouse in different situations. Thereby, we can change the parameter X according to the different position of the mouse in different situations. Now, we are going to introduce how to use the bulletin board to achieve a fake 3D effects. First of all, we need to create a buffer for the bulletin board. Host and size respectively represents the position and size of the bulletin board. Camera right represents the left-hand direction of the observer. The key feature of the bulletin board is that it always perpendicular to the direction of view or parallel to the camera right. Therefore, we can use camera right, size, and pose to calculate the position of the four vertices: the left bottom, right bottom, left top, and right top of the bulletin board. Then, we upload the data of bulletin board into the buffer we created before and draw it in the final scene. Thanks for watching.